Today we are going to be discussing physical versus chemical changes. A physical change is going to alter the material without changing its identity, a non-fundamental change. This is going to be something where even if I break it, I do something to it, it is still fundamentally what it was before I performed that action. Whereas, or an example, we have some phase changes. These include melting, freezing, evaporating, condensing, and boiling. They also include tearing, cutting, or breaking, along with grinding or bending. If I performed any of those actions upon a material, the material is still fundamentally that same material. If I tear a piece of paper, it is still a piece of paper. If I grind down a rock, it is still fundamentally chemically that rock. It's just smaller now. Or if I bend a wire, it's still a wire, it's just bent now. Whereas with chemical changes are going to be a change in which the substance is converted into something completely new. And will have completely different characteristics, different properties because of that change. So some examples of a chemical change could include burning or rusting. If the nail is rusted, that burnt orange color that is on top of that metal now, that is no longer iron. Instead, it is a new compound, which is more brittle, dusty, not as strong. Those are chemical changes that fundamentally change who it is. An example of changing different characteristics for a chemical change. Ordinary table salt is made up of sodium, which is an alkali metal that reacts aggressively with water, and chlorine, which is a gas. And chlorine, if you breathe it in, is extraordinarily toxic and will cause you great suffering if you were to breathe that in. So we have two things that both can cause injury by themselves, but when they are reacted together, when they've changed into something new, they become something that we sprinkle on top of French fries or other food products like potato chips or something like that. So because of that chemical change, we got a new characteristic property, and that just doesn't happen with physical change. We have some generic indicators of chemical change. These are just some of the ways that we can tell if something has become something new, if it has made itself into a new compound. It could change color, like in that of rust. It could form a gas. Bubbles are an indication of gas, although they are not the only indication of a gas evolving. Example of gas evolving would be if I was to mix vinegar and baking soda, those bubbles that come out, those are carbon dioxide bubbles. That is an indication that we have had a reaction and we have produced a chemical change. Formation of a precipitate. A precipitate is a solid forming generally from two liquids mixing together. And suddenly there's a solid at the bottom of your beaker. And finally, we have a change in temperature. So oftentimes some reactions are exothermic, which means that they produce heat, or they are endothermic, which means that they suck heat in from the environment, and you can feel that on the reaction flask. The flask will heat up or it will cool down to your touch.